So, today we will discuss about the speed control method of three-phase induction motor. So, let's start. There are two types of speed control method. First, stator voltage control method. This method is used to control the speed of three-phase induction motor. From torque equation of three-phase induction motor, Td equal K into S into Et square into R2 upon R2 square plus S square into X2 square, where K equal constant, S equal slip, E2 square induced EMF, R2 rotor resistance, R2 square resistance, S square into X2 square rotor leakage reactance. General induction motor operates at low slip region. At low slip region, Td equal K into S into E2 square into R2 upon R2 square plus S square into X2 square. Resistance R2 remains connect, rotor resistance remains negligible, and now the equation becomes Td equal K into S into E2 square upon R2 square. From this equation we can say Td proportional E2 square. If EMF induced more, then Td torque is also increased more, and opposite is also same. If EMF will reduce, so torque is also reduce. And EMF क्या है? EMF depends upon magnetic flux. If more flux cuts the winding of rotor, more EMF will induced, and magnetic flux depends upon supply voltage. Voltage, flux, EMF, torque. मतलब कि if voltage increases, so voltage increase, so flux also increase, EMF, and then torque is also increased. If voltage will decrease, so voltage go down, then flux, then EMF, then torque is also go down. Now the torque speed characteristics of a three-phase induction motor. Here V1 is bigger than V2, V3. It means when we change the voltage, torque will also change. AC regulator is used to control the voltage. Three-phase induction motor. In this three-phase induction motor, we use 2 SCR thyristor is used for each phase, which connect in anti-parallel direction. Thus, by the help of AC regulator, we control the speed of motor. Characteristics: torque, speed V1, V2, V3, low speed, medium, and N1 is high speed. मतलब V1 is bigger than V2 and V3. That is stator frequency control method. When we connect three-phase induction motor with three-phase AC supply, around the stator winding a rotating magnetic field produced when we give the three-phase AC supply that rotates by synchronous speed. The equation of synchronous speed is given by Ns equal 120 F upon P. F equal supply frequency and P number of poles. When RMF cuts the rotor winding, EMF will induced in rotor bar. So, EMF equation of three-phase motor 4.445 F kW into T, where kW equal winding factor, T total number of turns, V proportional phi. It means flux depends upon supply voltage, phi equal V upon 4.44 F kW into T. So, from this equation, phi equal 1 upon F. So, when we decrease the frequency, flux will more generate, and then when we reduce the frequency, only large flux will generate. Due to saturation of current, large current flows which can damage the winding. That's why when we decrease the frequency, as well as we will decrease the voltage with VYF ratio. This method is also known as VYF ratio. Frequency variation by VSI, frequency variation by CSI. So now VSI. Voltage source in inverter. We give the three-phase AC supply to the rectifier, and then rectifier converts AC current to DC current. When we take that DC current in inverter, and inverter again convert DC current to AC current. Inverter circuit consists of thyristor and switching devices. Disadvantage: cogging occurs in motor. And what is cogging? Cogging is flux interlock to each other when frequency less than 6 Hz. Now frequency variation by CSI. Heavy ring is used between rectifier and inverter circuit. Thus current comes into the inverter, so we adjust the VYF ratio in inverter circuit. Here phase induction motor and frequency variation by VSI and frequency variation by CSI. So now see you in the next video. Wish you all the very best.